through yesterday is like how to sketch from f dash x function back to fx function, give you the f dash x function, and you can find the integral of the other one to sketch it. And I have go through like compare the two different questions. Like fx to f dash x is easy. F dash x back to fx, you need the table to help you to see the shape of the original graph. That's what we talked about yesterday. And also we have talked about how to give you the derivative function and give you a point, how you can find the actual y function, or the fx function. So we substitute the given point to find the c values. That one is easy. And we rush through this question here, which is like talking about the population growth. As I said, population growth is always, most of the time will be modeled by the exponential function, because there's a restriction, like there's a limit, horizontal limit, and your increase, like you increase forever, is not going to go infinity. It will be approaching to a particular value and then become stable. And we have find antiderivative, sketch the graph, and substitute a value in and find the solutions for t. Okay, they are all algebraic expressions. So that one's fine, and we find this is actually, I think it's an exam question. So this is the f dash x function, and we find the antiderivative of that, and we use the table to work that out. And the answer should be A. So that's all we learned yesterday. Well, there's another thing we can talk about in motion. Like example 11 is a really good one. So we'll talk about example 10 and 11 tomorrow. But today, let's just start with the average value of a function. So this is the last definition, like a new definition in chapter 11. So average value of a function. Okay, this formula is very important because every year there must be a multiple choice question on that, and it's a very easy mark to get. It's just one formula, not relate to anything. Okay, not relate to anything, is a single formula. Students always forget this one and always confuse this with the average rate of change or instantaneous rate of change. When they ask, average value, they're trying to find the average gradient. So that's something like, because this formula is by itself, okay, it's not connect with any other concept, so always forget. It's a small thing but important, but like it's really easy. So what this one talk about is, well, we have a function fx. For example, we have some, like I just give you some random function fx. Maybe a circular function is this. Okay, I want to talk about in between A to B. What's the average value? Okay, so for in between A and B, you have infinite many of y values, right? You sub different x value, you get different y values. So how to calculate average value? Do you remember? Like for example, I'll give you 10 numbers and ask you to find the average. How do you do that? Give you 10 number. 1, 2, 3, 4, 5 until 10. Add them together and then divide by 10, right? So that's the average. So, but for this one, what's the difficulty to do adding and then divide is we can't add infinite many numbers because we sub x equals to 1, x equals to 1.1, x equals to 1.15. Like I can sub all different values. There are so many, like basically it's infinite many points there. Like I can't add them and I don't know what to divide. I need to divide infinity. So it's not achievable. And remember I said the sum sign is some finite numbers, like countable numbers. But if we want to sum infinitely many numbers, that will tend to integral. Okay, it tends to integral. So again, this is the similar idea. Okay, I'm not sure if you can get this, but it's the similar idea. If I want to sub all the values in between A and B for all the y values, it's actually the area. Remember, like we talk about, like we have rectangles, but when the rectangles tend to be really, really small and become lines, is actually the area. So the sum of all the y values is actually from A to B of fx dx. Okay, it's still the same idea. I'm trying to adding everything. After adding everything, I need to divide by the number of numbers. Like I can't divide by infinity, but what I can divide is I can divide by the interval b minus a, like it's actually the length of this interval, and that will give me the average height. It is from the algebraic way to think about that. But if we can think about graphically what this really means, I think it's easy to understand from the graph. Okay, from A to B, I have this area. Okay, from A to B, I have this area. So the length is B minus A here. Okay, so B minus A is the length, and I have created this area. So for the same length, I want to make like, okay, this irregular shape. I want to make it a regular shape. I want to move the area and make it become a rectangle. Okay, I want to make it become a rectangle. So I may have this black rectangle, and that gives me the same area as the red one. Like for example, I don't know whether if it's true, like, but what I'm willing to do is make a rectangle, use the same length, like same interval, a rectangle shape to contain the same area as given by this function. So this black rectangle is my new area, but it's equivalent to the red area. Then this height is called average y value. Okay, because for a uniform height, you can create the same area as the function produced. So then we treat that as an average y value. I think this is a better explanation to talk about average y value. So different height produce like that area. Now I want a uniform height to produce the same area for me. So that is my average y value. Okay, so that averages. So it's just like we make the shape, we press the irregular shape, make it become a rectangular shape within the same width interval, so which is b minus a. So you know, like what I can say here now is, let me just clear that. What I can say now is, well, I want the two heights to be the same, so I'll say average y value, which is the height, times b minus a. Okay, that's the black rectangle's area. That should be equivalent to a to b of fx dx. Yeah, so the average y value will be the integral divided by b minus a. So we have the same result. Okay, we have the same result. You can think in two ways. One is from like what is average, and then another is from the graphical meaning. So in graph, what that actually means is use the same length interval. I want to produce a rectangle to give me exactly the same area produced by the area under the curve. So that is my average y value. If you can't get both of these explanations, that doesn't matter. You just remember the formula. Okay, easiest way, remember the formula. But if you understand it, it's easy to remember it. Okay, so basically just the area under the curve divided by the length to find the height of the rectangle, and that is the average y value. Okay. So sometimes average y value can be negative because here we talk about the signed area. We don't talk about the actual area. Okay, it's not talking about the actual area. I'm talking about the signed area. So we just simply do an integral. Any starting point, finishing point, we just integral that. We don't need to consider above, below, like the integral will calculate for me. Okay, I don't need to consider about that. Just show like one example here. Okay, find the average value of the function on the given interval 1 to 5. Okay, very easy. We just integral 1 to 5 of x squared dx. Find the area under the curve between 1 to 5. And then we need to divide by 5 minus 1. So that's the how long gives you that area. So for 4 units, you have this area. So you divide by the width, and you want to find the height. So that's a quarter times a third x cubed 1 to 5. I can get the number outside the bracket. So you have a 1 on 12, x cubed, 1 and 5. That is a 12. 5 times 5 times 5 is 125 and minus 1. So it's 124 divided by 12. Okay, divide by 4, that's a 3. Divide by 4, that's a 31. So the average y value for this function in between 1 to 5 is 31/3. Any questions? This idea should be like much easier compared to what we all learned before. It's just a formula. You don't need to connect it to any knowledge. Just sub that in. When you see average y value, think about that formula and put the values in, and that's it. Okay, if you think about fx equals to sine 2x, in between 0 to pi. So it's pi minus 0 divided by that, and times with integral 0 to pi of sine 2x dx. That's 1 over pi integral of, what's the antiderivative for sine? Negative cosine. Okay, so I'll just ask you every time I see sine and cosine. Okay, negative cosine. So it's negative 1/2 cosine 2x. 0 to pi. So we can say that's negative 1 on 2 pi. Cosine 2 pi minus cosine 0. What's cosine 2 pi minus cosine 0? What is it? 0. They are the same thing. 0 and 2 pi, they are the same angle. So that's a 0. Let's think about why we have a 0 here for the average y value. If you think about the sine 2x graph, okay, that's pi. Because period is pi, just draw one period. That's pi over 2. Okay, so okay, that's a sine 2x. What's the area, sine area in between 0 to pi? Zero to pi, like that graph. What's the sine area? What's that? What's that? They are equivalent, right? But one above and one below, so that gives you an area of 0. So I don't have any area, so my rectangle does not need a height. So that's why my average y value is just 0. So it's making sense here. So I said it's talking about sine area. So in between that and that, I have a 0 area. So 0 area means I don't need height. Okay, so the height is 0. So I just have a line. Okay, let's have a look at the next one. Find the average value of C such that f average equals to fc for fx equals to x squared minus 4 on the interval of 0 to 3. So f average on the interval 0 to 3 equivalent to fc. Okay, let's talk about f average first. Okay, f average is 1 over 3 minus 0 integral from 0 to 3 of x squared minus 4 dx. That's the average y value on the interval 0 to 3. And then that equals to fc. fc is c squared minus 4. FC is c squared minus 4 because fx is x squared minus 4. So FC is c squared minus 4. So that's a third times with a third x cubed minus 4x from 0 to 3 equals to c squared minus 4. That's a third. We put 3 in. That's a 9 minus 12 for the first substitution, minus 0 for the second substitution. Okay, sub 3 get 9 minus 12, sub 0 get 0 minus 0. That equals to c squared minus 4. You can see where's x squared minus 4. We have a shape like that. That's minus 2, that's 2, and that's minus 4. 0 to 3 is this area. Okay, 0 to 3 is that area. So you can see my area is a negative area, so it's a negative 3. It makes sense, okay, it makes sense because we have a larger bottom. So minus 3 times the third, we have minus 1. C squared equals to 3. C will be plus minus root 3. C will be plus minus root 3. Okay, it makes sense? 2x will give you the same y value. And because it's a quadratic. Next one is kind of application question. It's not really. This one is to make you distinguish between the three definitions. The three things is really easy to be asked together in the same question in three different parts, like A, B, C. And a lot of students confused with that. So first one is average y value. The second one is average rate of change. And the third one is the instantaneous rate of change. They kind of share the same thing, or like they are not really the same thing. Okay, they're very, very different. They all said average, like average y value, average rate of change, but they're using different formulas at all. So look at this question. The temperature measured in degrees of a house and over 24 period is modeled by cosine function, okay, between 0 to 24. So T is the number of hours after midnight. So midnight is 12 a.m. So after midnight, the hot house has varying temperatures according to the outside environment as well as the internal heater. So the temperature change, okay? The heater works and also the outside environment will influence the temperature. So the temperature keeps changing. So what is the average temperature from 1 to 6 p.m.? Okay, average temperature. There's nothing talk about rate. So it's talk about average y value. Okay, if it's average rate of change, it'll make the word rate really clear. So if this one is just talk about what is the average y value. So average temperature in between 1 to 6. So first of all, 1 p.m. T equals to what? 1 p.m. T equals to what? 13. And equals to 6, T equals to 18. Okay, good. So it's actually not in between 1 to 6. It's talk about the average y value in between 13 to 18. Okay, not 1 to 6. It's 13 to 18. Because it's the hours after midnight. So average average y value, so is 18 minus 13. It's expressed 5 hours. Integral from 13 to 18. 15 minus 25 cosine pi t over 3 dt. Okay, this dt or dx is really according to what you have in your function. So do not write that wrong. Okay, if you write that wrong, you still lose mark, because if you antiderive that for a different thing, like it's different answer. So it must have dt there. Okay, therefore we have 1 of 5. Let's sub things in. 50 is a 50t minus cosine will become what? Positive sign. So we times 3 over pi. Okay, flip it, and then times sine pi t over 3 from 13 to 18. That is 1 of 5. Okay, sub the first thing. 50 times 18 minus 75 over pi times sine 18 over 3 is 6 pi. 6 pi is just a 0. Here, 6 pi is just a 0. Because 18 sub 18 is 18 over pi is a 6. 6 pi is 0, so 2 pi, 2 pi, and 2 pi, so 3 period. And minus, you sub 13, so it's 50 times 13, minus 75 over pi sine. Okay, what we have here is 13 over 13 pi over 3. So it's 12 pi over 3 plus pi over 3. So this is just become a pi over 3. Right, 4 pi can just disappear, like 2 periods. So 13 pi over 3 is 12 pi over 3 plus pi over 3. So that's just a pi over 3. What we'll have is this one will be 0. Okay, sine 0 is a 0. 50 times 18, 50 times 13 is 50 times 5. We subtract, we can take 50 as common factor. It's a 50 times 5. Okay, 50 times 5. So it's 1 of 5 times 50 times 5. We combine those two, is 250. Minus, no, it's a plus 75 over pi root 3 over 2. Sine pi over 3, that's root 3 over 2. Okay, it's row 1, last column. Okay, 30, 45, 60, root 1, root 2, root 3. So it's root 3 over 2. Okay, so we expand that. We have a 50 plus 15 root 3 over 2 pi. Okay, the 75 times with divide with this 5 become a 15. So it's 15 root 3 over 2 pi. Okay, that is the average temperature. Okay, so you can find approximation values if you have calculator. But if you have calculator, you don't need to go through this long working here. Just type that into the calculator and find approximation. Next one says, what is the average rate of change of the temperature between 1 to 6? this is talk about the gradient of the linear connecting the point t equals to 13 and t equals to 18. So it's the average rate of change. So average rate of change formula is is that F? Yes, F18 minus F13 over 18 minus 13. Why mark the paper? Okay, I see some of you get the mistake. Average rate of change and doing all the things kind of correct. So F18 minus F13, but the bottom is 13 minus 18. Be careful, do not make that mistake. Okay, you should have the same coordinates on the same side, like 18, F18, 13, F13, they're on the same place. So it must be F18 minus F13 divided by 18 minus 13, can't be 13 minus 18, otherwise you get the negative of the actual value. So F18 is 50 minus 25 cosine 18 over 3, 60, 6 pi, so still 0, minus 13 is 50 minus 25 cosine pi on 3. Again, same reason, 13 over 3 pi is 12 pi over 3 plus pi over 3. So 4 pi can just cancel, so we just have pi over 3. And then divide by 5. They all divide by 5, but one is y2 minus y1 divided by 5, and one is the area divided by 5. So they are different. And you can see this 50 and this 50, they can get cancelled. What we have here, cosine 0 is a 1. So it's a minus 25 plus 25 times by cosine root 3, okay, it's the last spot, but the second row is the reverse way. Root 3, root 1, root 2, root 1 over 2. So the last spot is root 1 over 2, so it's a half. And over 5. So we can divide by 5, both top and bottom, so it's minus 5 plus 5 times a half. Should have minus 5. I don't have space. You can do the calculations. That's minus 5 over 2. So negative 25 plus 25 over 2 give you negative 25 over 2. Negative 25 over 2 divided by 5 is negative 5 over 2. So the average rate of change of the temperature between 1 p.m. to 6 p.m. is negative 5 over 2. So it's a decreasing rate. So the temperature is kind of decreasing 2.5 degrees every hour. Okay, it's decreased 2.5 degrees every hour. What's wrong? Okay. Yeah, so that's the average rate of change. Then you can see it looks quite similar, like average rate of change and average y value, all divided by 5, all divided by b minus a, but one is the area divided by that, and the other one is the f2 minus f1 divided by that. Okay, you have to look at the last one. What's the rate of change? Okay, at t equals to 18, doesn't have another point and no average, so it's just instantaneous rate of change. Okay, there's only one point given. So I need to find f dash t. F dash t give you 25 times pi over 3 times sine pi over 3 t. Okay, cosine will become minus sine, and the minus will get cancelled with the front minus. The 50 becomes 0. You diff that. You can see the average y value we anti-diff, but for the instantaneous rate of change we diff. Okay, we diff. So f dash 18 at 6, so it's f dash 18, gives you 25 pi over 3 times sine 0. 18 over 3 is 6 pi. 6 pi is 0. So f dash 18 is just a 0. Yeah. Is that this one? It's same as 0. Yeah. 6 pi 0. Like I keep using zeros, like, and also anything I can simplify directly. Well, it's alright, right? 6 pi here, but like that will be 0. So the derivative will just be 0. You can write another step here. So that's sine 6 pi to do first substitution. Well, unless you're really confident of your converting, okay? Otherwise, still write that step. You will still, well, if you do that and do that wrong, you won't get method mark because I don't know where that 0 coming from. Say you think it's a pi on 3, but it's not. But I don't know where is your pi on 3 coming from. So you do a substitution first and then simplify. Maybe it's a better idea for like you. Unless you're really confident, okay? 100% sure I'm doing right. So that's fine, directly convert that. Encourage you to write another step. Okay, so that's just like, it's not really very meaningful for this question. It's just give you the 3 formulas together, compare them, and then we need to pay attention. Sometimes they ask questions together. Normally it's A and B, they ask together for average rate of change and average Y value, because students always confuse between those 2 formulas. Okay, let's have a look at example 15. Consider a function g defined by that. Can you tell me what kind of graph is that? Like what function is that? What's the name of the function here? Look at carefully what is your variable. What is your variable? What is x or k? X. K is the constant. Okay, k is the number, although it's changing, but like for every time you just have one k value. No, like if it doesn't say constant, you know that should be a constant because you already define what is the variable. Like what is in the function, that is the variable. Gx, x is the variable. Okay, now let's tell you k is a constant, x is the variable. What kind of equation is that? What's the name of the function? Linear, good. Okay, gx is a linear. You should be able to see that. Okay, now we can see that's a linear. Okay. Find the values of k such that 0 to 1 gx give you 1. Okay, integral 0 to 1 of gx equals to 1. Well, we can do it about 2 ways. The first way we can do it is just algebraically do it. But like, I think it's not that fun. This will be the linear. Well, it can be different slope and the y-intercept can change. But the y-intercept is definitely positive because give you k greater than 0. Okay, give you k greater than 0. So, and it's a decreasing function. 4 over k squared is definitely positive, and negative of that is a negative number. Negative gradient, positive y-intercept, the graph can only look like that. Okay, 0 to 1. I might have different k values. Say if 0 is here. It's basically talk about where, it depends on where is 1. You know, like where is 1. Whether 1 is on this side or 1 is on this side, that will be different. If 1 is here, then I just talk about this area to be 1. If 1 is on that side, so it should be this minus this triangle minus the small bit is still like give you 1. So then I see the diagram. I feel it's hard to think about from the graph directly. So maybe directly integral that is easier. Okay, even though it's not that fun. But I don't want to increase the complex, make you really confused with it. So 0 to 1 of gx, that equals to 1. So you want to integral 0 to 1 of, okay, what do you want to integral? What I want you to do is I want you to separate the actual constant and the variable. Because even though we have k, we don't antidiff k, we just antidiff x. We treat k as like a number, 2, 1, like that's a number. So we integral that will give me 1. So what I should have here, this is a constant, we make it stay there. And x becomes x to the power of 2 divided by 2. And 4 over k is a constant, so we times that by x. 0 to 1, that gives you 1. So simplify that a bit further. That's minus 2 over k squared times x squared plus 4 over k x. 0 to 1 equals to 1. So we sub 1 in. We have minus 2 over k squared plus 4 over k. Sub 0 in, that's 0, so don't write it. That equals to 1. That's the area between x equals to 0 and x equals to 1. Okay, it's changing according to k. Like different k will give you a different area. It's changing. So, what do you do next step if you want to solve this equation? How you can solve this equation? Solve for k. We finish up, it's just the equation, minus 2 over k squared plus 4 over k that equals to 1. What's the first thing we're trying to solve equations? We'll see fraction. Denominator. I need to get rid of the denominator. So how I can get rid of the denominator here? Times by what? How I can get rid of the denominator? Times by what? K what? K squared. Year 12 students should be able to do that, okay? Okay, we times k squared on both sides. Doesn't matter what you're trying to do. You see denominator, you get rid of the denominator. That's the first thing you do. Otherwise, you can't see what the equation should look like. So what we have is minus 2 plus 4k equals to k squared. K squared minus 4k plus 2, that equals to 0. Okay, I can factorize, or you can use quadratic formula, same thing. So k equals to 2 minus root 2, or k equals to 2 plus root 2. Can I take both answers? Can or cannot? Yes. Okay, even though it says k greater than 0, but like my k is all greater than 0. 2 minus 1.4, that's greater than 0, and 2 plus 1.4, that's greater than 0 as well. So my k can be two different numbers. Okay, so the solving is interesting here. You should know, get rid of the denominator, times by the common denominator, and then we can see equation we're familiar with. Okay. Next one says find the k-value or k-values such that 0 to 1 dx is greater or equals to 1. Okay, I know what's the area of that. The area of this is this. Okay, it's coming from this step. Ignore the red because we times k squared later. But we just integral this on the left hand side. We keep working, then we have minus 2 over k squared plus 4 over k. That's the area under the curve between 0 to 1. Okay, we have worked out that already. We don't need to calculate that again. We just change the sign and the numbers later. So we still can times k squared because that's definitely a positive number and I don't need to change the sign. So it's minus 2 plus 4k greater or equals to k squared. So k squared minus 4k plus 2 is less than or equals to 0. So I move everything to the right hand side. So it's k squared minus 4k plus 2 less than or equals to 0. And I know I have factorized that. That's minus 2 plus root 2 k minus 2 minus root 2 less than or equals to 0. So we factorized that before. I have completed the square, k minus 2 squared minus 2, so plus root 2 minus root 2. And if we sketch that, well, solving inequalities, unless you're solving for linear, all the other polynomial inequality, quadratic inequality, you need to use diagram to solve. So we have 2 minus root 2 and 2 plus root 2. And this is the quadratic. So this is the quadratic. And I want this thing to be less than or equals to 0. So which is everything here. Less than or equals to 0 is everything here. Below the x-axis, therefore the x I can take is all the things here. And it's all positive. And all is all positive. So what I should have is k belongs to belong or equals to 2 minus root 2 to 2 plus root 2. Okay, because it can be 0. If it can't be 0, so I can't take that. So it can be 0, I can take both endpoints. It's nothing to do with the average rate of change. This is just a question to solve inequalities. I think it's more like a solving question here. How do you solve? Okay, the rest of the time I want you to do page 28. Well, example 2 is a super easy question. It's not really even needs to be done by calculus. Try focus on example 1 and focus on the explanations of b equals to 2.83, what that means. And I can quickly go through that tomorrow. So complete the last page. Okay, complete the last page. And tomorrow I'll check the answer with you and also go through the 2 examples for motion questions. Any questions for today? Okay, one important formula we learned and it's definitely appear in VC exam is the average y value. It's one single formula, not connect with any other knowledge. You just need to know how to integral and how to sub things into the formula. Okay?